Hi, everyone. Welcome to our 14th InterVenture Webinar. My name is Tamara, and I will be your host tonight. We are a Swiss company that builds tailor-made distributed teams in Belgrade for our partners. At the moment, we have over 35 open positions, so you can take a look at our career page on our website if you're looking for a change. Tonight we have a pleasure of hosting Nikola Kolevski, who is a software architect at TradeCore, currently working on the TradeCore platform. He will talk about different looks at test-driven development for those that failed and those who found it too constricting. For questions, you can use Q&A option at the bottom of your screen or type your question in your chat box. My guest will answer them at the end of the webinar. And also recording of this webinar will be available on our YouTube channel tomorrow. Nikola, welcome again. Thank you for accepting our call, and we are looking forward to hear what you have prepared for us tonight.
So hi, everybody. I'm Nikola, and I've been a Pythonist for about 10 years now. And currently I'm working as an architect at TradeCore, which is, well, effectively Serbian entirely. Fintech startups, let's scale up. Our idea is that we're AWS of fintech, if you will. It's kind of pretentious, but you know, the whole idea is you can build a fintech startup off of our technology. But I'm effectively a gardener. You know, I'm there to make things nice around TradeCore. I still write code on a daily basis, so I'm not too out of touch, I hope. And the workflow I'll be showing and talking about is basically a combination of 4 years of working in a fast-paced fintech. You can find me on GitHub or LinkedIn. And just don't go looking on Twitter. That's all I'm saying. So there's going to be a bunch of text here, and I'd argue don't read it. Like, let's talk this through. You'll have the slides available for later. We'll try to put them up immediately after the webinar, and you can send any questions you want in the chat. I'll try to keep track of them and answer them if it makes sense. If not, I'll highlight them and say that I'll answer them by the end in the Q&A session. So let's switch to my question to you. Like, what stops you from writing tests? As I sort of expected, it's not mostly, this is kind of way more mixed than anticipated, but time constraints, right? Tests are a hassle. It takes time to write them and stuff like that. So hopefully I'm going to be able to show you some ways how to make it easier, like less fragile, easier, and hopefully more fun. And for those of you who don't know how to start, hopefully this will be an introduction to see that they're not something scary. They're rather simple. They're code that runs your code. All right, so this talk is going to show how tests can be an integral tool for development rather than just quality assurance. Because right now we're kind of, at least that's what my understanding was initially, that tests can only be useful to tell you if your application is working or not. They're helpful for quality, but not necessarily development. But that's not mutually exclusive, right? You can still write tests that are useful for you and prove that your code works. So we'll try and show a toolkit that minimizes friction in writing tests. This whole talk is going to be very developer-centric. We'll try and break, like, this is first and foremost a Python talk, unfortunately, but we'll try and break it down for non-Python folks in hopes that you can find the same or similar tools for your framework, language, stack, whatever. And as soon as you recognize an equivalent tool, please write it in the chat. Like, I'm super curious to hear. Like, right now, I'm not even doing Python at TradeCore, so I'm super eager to hear any of these things you recognize in Node or whatever. Let me know. I want to hear. All right. So this talk is not going to be a deep reiteration of TDD. It's more like tips for approaching tests in general. It's not going to use a strict vocabulary either, and it's not going to set a mantra on how to test software. So this is my way of inspiring you on how to reason about tests. I'm not here to tell you what to do. And this talk is for you if you write Python REST APIs in Django as your day job. It's still for you if you write Python in general. It's for you if you write code. And it's especially for you if you don't write tests as much as you feel you should. It's probably not for you if you already rigorously test your software, but you know, stick around, audibly ask about my preposterous propositions, and let me know what I'm saying is wrong. Just remember that the goal is to make people see tests as a tool. With that said, you already test your software. You probably do. have you ever deployed something without verifying that it works? There's a surprisingly large amount of people that say yes. That's really that takes some goal. Okay, well, my assumption would be that you at least checked, you looked, you peeked, and you've seen your code work. Like, sure, sometimes things just work, but that's not usually the case, let's be honest. What usually happens is that you try it out, you click it, you run it in Postman or whatever. You just see that the thing is actually working. So my argument here is that test automation is literally just a step away. Instead of trying your product by hand, write some code that runs your code. You'll end up with a written and repeatable testimony of successful execution of your code. Like, you have more confidence that it actually works because you have it basically in writing. With that said, there are some tests that are more valuable to developers, because a test that a QA runs is like, just tells you, hey, your thing doesn't work. It's effectively just a pass or a fail. What about actually getting a full-blown diagnostic suite out of it? Like, think about all the insight you might want out of a test suite. Like, it failed, sure, yes. Where? Can we see the stack trace? Can we step along the way to inspect what happened? Like, your test in general should run in a debuggable environment. You should be able to run your code and drive your code with your tests. So with that said, the debuggable environment is kind of bit down to how much access do you have to what you're testing. When you're running end-to-end QA or acceptance tests, whatever you want to call them, the big ones that proper QA writes, you are running them against an existing environment. So effectively, you could run them against your local environment. It'd be a bit of a hassle because you have to run the environment, you have to run tests separately, you have to debug the environment, but it kind of works. You could also attach to a remote environment, but that usually requires a whole separate talk to enable remote debugging. Ideally, you just press play and everything runs at once and only for you. Because if you run it against a remote environment, you might actually use the same resource as another dev. So you want to have as little contention as possible so you can try your stuff for yourself. With that said, end-to-end tests are probably not the kinds of tests that you're going to see value out of. You will know if you broke something catastrophically, but you won't know how or why. So what else could tests actually tell you? Like, well-written ones are basically your second documentation. Like, you can see examples of your code in action. Less well-written ones can still drive you through the code base, right? Because if they're triggering the functionality you want to see, you can plop a breakpoint and see the code actually execute with it. Either way, they should increase your confidence. A complete lack of tests should still not deter you. You can still write your first driver test and get a better grasp of what it is. So the takeaway here is that tests can actually drive you through your code base. And with that said, a driver test would effectively be a happy path test, a smoke test, call it what you will, a test that just runs the code and allows you to drop a breakpoint and poke around. If there's no tests, you can still write one without knowing anything about the system, because you already know how to run the thing you're trying to see work. You don't necessarily have to know what are the conditions for its successful execution at the beginning. So it's okay to have no clue what the test is going to be. It's literally just going to be a test, whatever that means. And you should think of it as a programmer's way of using the application. You're just poking around the user interface, except the user interface is the program, the test you're writing, right? Or rather the API you're interacting with, but you know what I'm saying. So the quality of that test does not really matter. Just write something out, try something, see what you can get out of it. And it's okay to delete that test. It really is. You're just using it for yourself to get a better understanding of how the damn thing works. So what does a driver test look like? It's literally just running your code. You're writing a piece of code that will run your code. So this is a test function. It calls the feature you want to see working. So that's sort of helpful to see if the thing will blow up, but it doesn't really verify anything, right? It's not really a test. So if you wanted to turn it into a test, you would try and take something out of the thing and confirm that the result matches the expectation, or you would observe something around the system. But either way, this is all you're doing. You're executing the code and you're confirming that the results match expectations. Right. So what's it good for? It's, as I said previously, it's good for dropping a breakpoint. Here, breakpoint is basically this, if you're not familiar with PDB, but it should be the red circle on the left side of your editor, or those of you that use normal debuggers and editors. But that's the whole point. You just have a way to go in the middle of your code where there's a thing that worries you and see how it behaves, how it works. Why does it not work if it doesn't work? And if you didn't have a test previously, this test will get you there. And once you know what's actually broken, you can understand the thing that broke. So you go back to the test. You go back to the driver test that was nameless. It was, what would we call it? We called it test feature, right? So now we call it test the feature for the thing that worries us. We prepare the conditions to trigger the thing that worries us, and then we assert the results. This is the general loop you would always have. You would prepare, you would execute, and then you would confirm that it actually works, or arrange, act, assert, given, when, then, for those of you that actually have worked with some of the methodologies. So seeing what you wanted in the debugger is just part of the story. Always go back, consider the conditions and expectations, and adjust them. Check your assertions. Do they still test what you want? And then actually promote your driver test into an actual test, perhaps a regression test, because usually you write driver tests when you have a thing that already works, but somehow got broken or whatever, and you want to see what exactly has been broken. So it usually results in a test that you use to confirm that there's a bug and this is what happened. But I can't stress this enough. You really have to go back to the test, understand why you made it. Like initially we said that there's the reason you made it is to actually run through the code. But now, once we're done with it, we're either removing it or we're actually understanding why we made it. Again, I said I won't direct you, but this is probably one of the main things. You don't want to write a test that's useless. Like if you can't describe the case, you either don't understand what it verifies, you aren't actually verifying anything, or you're verifying too many things at once. Right, have we got our questions? Okay, so the question was, are driver tests what Michael Fetters calls characterization tests? In example, what the legacy code actually does. Not initially. Initially, they're just shells for you to execute your code, but they're there for your leisure. But yeah, and the result is probably the characterization test. I hope that answers your question. Right. So without further ado, let's actually switch to the tools, or what makes tests hopefully fun. So as you've said at the beginning of the poll, you said preparing tests is a hassle, takes time, you either don't know how to do it and stuff like that. So the examples I've given you in the slides previously, they're simple, but they can be very close to reality with decent tools, more specifically stuff like pytest. But we're going to go through what characterizes such tools, like what should you look for in your tooling. And probably the most important things are the low boilerplate, low noise in your preconditions, developer ergonomics, and interaction recording. So let's go through them one by one. Low boilerplate basically means that you can write a test without knowing a lot about the framework. You shouldn't have to know how is it supposed to look like? Does it have to name things this and that? Does it have to be in a class or whatever? It's just like, it's a thing that runs code. Who cares, right? And low noise in your preconditions means that you shouldn't take an hour to prepare the test. Like you shouldn't have to initialize the world to go and buy a sandwich. It's just too much work. It doesn't make sense. Development ergonomics is how fast can you drop into that test? Like how out of the way the execution of it is. If you need like a 30-line bash script to execute your test suite, that's probably not ideal, right? You need something that can just immediately drop you into the test. And finally, interaction recording. You'll see very little mentions of mocking in this talk. And this is probably the main reason. Usually you want mocking to record interactions with your, or rather not to record, but to mock interactions with your third parties. And I'm going to argue there's better ways to do it by recording the actual interaction and then replaying it. All right. So the first tool, the thing that kind of puts it all together, is the PyTest. PyTest is an amazing test framework. Like this is literally what a test in PyTest looks like. Like that's all you need. No setup, no nothing, just start testing your thing. And running it literally just discovers the test underscore files, finds the test underscore functions, calls them. That's it. You got a test running. It literally takes minutes. So as far as the ergonomics of PyTest go, you have a couple of things you can do. You can exit on the first error, fifth error apparently, and drop into debugger on failure. You can run the last failed, but your editor probably supports all of that already. So I suggest you find an extension. Like I only got Vim test on my mind because that's what I use, but basically VS Code almost certainly supports PyTest. Whatever else you use is supporting test frameworks to some extent or another. So try finding your own extension, because that's always going to be more comfortable for most of you than just running it in a shell. In case you need it in a shell, these are probably the 3 most useful switches you might need. So onto the magic of PyTest. Instead of having setup and teardown methods, it actually provides you with fixtures. Fixtures are supposed to give you the preparation data, and you can summon them out of thin air. So basically, a fixture is a separate function that lives in a separate file. In this case, they're calling it conftest.py. I honestly have no idea why. Probably has to do something with the history of the framework. But that's where you would put the global preparation data aside, and then you would effectively inject it, or rather PyTest will inject it for you when you just mention it in the test function. You literally just specify the picture you want to see as an argument to the test, and then you can use it. It'll use whatever your fixture function returned. So the cool thing about fixtures is that it can actually request another previously defined fixture. What that means is that you can cascade them. You can have a thing that prepares something. So say you have a user that needs, or rather, you have like a wallet that needs an account, that needs a user, that needs whatever. You can literally define them like that. Okay, I have my wallet. My wallet requires an account. Then you go back, implement account, and so on. In this particular case, we have the bank account, and it requires the database. So we literally just say, hey, we need the database. And then the database interface can get called and we can return an instance. This is obviously a fake example, but we'll get to more real ones. Right, so we have a, let me click answer live this time. Right, so does it re-execute fixtures each time? If it's unspecified, yes. Sorry, I was gonna click elsewhere. If it's unspecified like this, it will get re-executed. But I believe that it's an argument to the fixture where you say the scope of the fixture is session-wide or module-wide or whatever. So if you want to instantiate something like database, now that I think about it, I should have mentioned scope there. But yeah, you can scope fixtures to whatever makes sense for you. Usually, for me, most of the fixtures, other than global ones like database or whatever, are just function scoped, so they don't have anything there. Okay, so this is effectively the setup part. I mentioned the fixtures are actually replacing setup and tear down, right? So the tear down is actually done in the same fixture. So what it does is it splits itself, or rather you split it. So the first part would be the setup where you create the thing you needed. Then you yield, you return the thing you wanted, and then PyTest calls it again after, and the teardown happens in the second half. So you effectively get fairly readable setups and teardowns that are obvious in showing what they're doing. You'll see later why specifically for the Django flow, you don't need to do this for entities, but I'm getting ahead of myself. So fixtures can perform cleanup as well by yielding instead of returning. So how does the test look with fixtures? Basically, you say, hey, this is the thing we want to do. So in this case, test perform credit. And then you request the things you need. You need a bank account and you need a bank teller client. This is basically for bookkeeping for later. We save the previous balance and then we call the route for crediting the bank account. And then once we do the get call, we should get the balance that we've changed. And that's basically it. Like your test clearly states what it does. You can observe what it performs. It's just 4 lines. Again, probably a simplistic example, but it still drops a lot of those things that you would need for a setup up here. Your test focuses only on the thing that's relevant to your test. So the noise levels are low. When somebody's reading your test, it's fairly readable. So yeah, in this particular case, test is unaware of any database operations. Like he only wants a bank account. Like you're writing something that looks a lot like an end-to-end test without the pain of preparing it end-to-end, where you actually go through the whole ordeal of creating a bank account through the API or whatever. You can do something behind the scenes, set it up in the database, and then execute the whole thing. Okay, so PyTest has a bunch of plugins. You literally run them by or not run them, but include them by installing them. So long as they're in your virtual environment, PyTest picks them up and runs with them. They're mostly useful to provide you with other fixtures. So you can have fixtures coming from plugins, and you'll see how that looks in a second. It has marks, which is also something we'll show in a second. And many of the libraries we'll mention will actually be wrapped in plugins. So Faker, VCR, Django utilities are all like pytest Faker, pytest VCR, pytest-django. All of them exist as separate libraries, but you have pytest wrappers that make them conveniently available as fixtures. And you can still use them by hand, right? If you don't want to pull them in as fixtures, you can still import them at the top of the module and use them inside of the function, and Bob's your uncle. You don't have to do anything else. Interestingly enough, Celery even comes with a pytest plugin built into it. Like you don't even have pytest Celery. You literally, if you install Celery, you're gonna have what's the name? The Celery fixture available there. So let me just write. I just realized that I didn't put it in the presentation. You can literally say pytest fixtures to list all of the fixtures available to you right now. PyTest will go through all the plugins, through everything available in your environment, and tell you what you can use. Fixtures usually have a nice description telling you what they actually offer. Okay, so pytest-django is probably the biggest one for all you Django people. So it effectively replaces managed PyTest. It provides database setup and Django test case replacement through marks. It provides a Django test client fixture as well, and it wraps your test because it replaces test case, right, in a transaction and rollbacks once it's done. So more real test, or rather not more real, this is, now that I look into it, the same test as previously. The only thing that we've changed is we've added DjangoDB on top. This basically tells the test that it will interact with the database, and PyTest needs to do all the preparation steps that managed PyTest would. It migrates your database, prepares whatever it needs to, and gives you access to your models. I think it basically boils down to running Django setup. I'm not sure. But yeah, marks are effectively, they are obviously decorators, right? But they allow you to have some additional indication to PyTest framework, like, hey, this is another thing I want to enable in this particular test. And we'll mention them a bit more later, I believe, where you can do something more for yourself with the marks. So as I said, the test will be wrapped in a transaction, same as with a test case. And that's basically how you perform cleanup for 90% of the situations in your tests. You just create a model and you rely on the transaction to actually delete it. Okay. So brief aside on marks. You can have your own marks, which allows you for selectively running a test, or tests rather, right? So here I've added an integration mark. It doesn't do anything. It represents nothing. well, at least not to the framework, but it represents something to me. I know that this particular test is what I would consider an integration test, whatever that meant, right? So I would have to define it in pytest-django as a set of markers. So this is an example from one of the apps I made with pytest or tested with pytest. It's like tags in Django's built-in test runner. Possible. I actually haven't used Django's built-in test runner extensively enough to have used tags, but very likely. So basically, you just specify what those marks mean to you. And what you can do later is run with pytest-m and then specify, okay, I want to skip integration tests, like whatever's touching something else, run slow, whatever. I don't want to run it, which is fair. So you have a way of grouping your tests in a way where you can run them selectively. It's kind of useful. But besides that, as you've seen with DjangoDB, you can also make marks that actually indicate something to the framework. You can do some crazy stuff with it. I'm not advocating any of that. Like, in my opinion, just use them to mark your tests for now, unless you have some super advanced use case. Okay, so another thing that's actually, as I hinted previously, contributing to high levels of noise is creating database entities. You usually need only one entity, but it's related to a bunch of others. Like, it's a whole graph of things that you need to create. And you usually don't care about most of the parameters. So in case of a bank account, you have balance, which is probably the one you care the most about. Then you have the user, which requires you to create a user, where you now have to go ahead and look up what the user has to create a user. You need to see the bank, which probably requires you to know the bank identifier code. You need to know the IBAN, which you don't really care about. It's a fake account, and so on. You get it. It's annoying. It's super annoying to have to come to the point where your test is actually ready and you have the one thing that you actually wanted set. And that's where we have Model Bakery. This is amazing. It basically allows you to skip all of that and just say, hey, somehow make me a bank account and make sure that the balance is 1,000. That's it. It figures out relationships, figures out everything you need, fills everything that you didn't fill with random stuff, prefixes everything you did set with the values that you've set. So for more advanced use cases, you can still specify a field on a related table that you didn't create, that Bakery creates for you. So in the case of a bank, say you need a bank account, but you need the bank's BIC to be specific, you can use the forward notation, the double underscore you would use in Django filters to actually say, okay, on the bank's entity that I'm not creating, you're creating it, set this particular field to that value. It's really handy. And if that's not good enough for you, you can outright provide a pre-existing model by just saying, hey, the bank for this thing, it's actually going to be hard-coded to this bank. I don't care, right? Kind of useful when you want to create two bank accounts. One of them creates a random bank, but the second one needs to be related to that bank. It's brilliant. I hope I explained it well enough, but please check this out if I didn't. Like, I can't stress this one enough. Like, this is the holy grail if you're doing anything with the database in Django tests. So what about mocks? We've come this far in a testing talk and we haven't mentioned mocks once. Thing is, not that I hate them, but having mocks, it pokes holes in reality. So I like what Guillermo Roch said here. Write tests, not too many, and mostly integration. It basically sums up how you can have a healthy test suite. We already agreed we want to write tests. The argument here is don't write too many. Like, I think I didn't have a question about refactoring, but I believe that a large pain point for most of you is actually refactoring with tests. Tests break. Tests just break all the time. And that's probably the worst part of them when they break. But the reason for the breakage is the actual problems with the changing of internal details that are not relevant to the test. And that's where the mostly integration part comes. You want to have the integration level tests, which won't go into the nitty-gritty, into the details. And therefore you refactor so long as it doesn't change the behavior shown to the user, will be just fine. So I'm not sure how well this resonates with you, this particular tweet, but I hope that it hits some of you straight in the feels. Just stop and try to think about this for a second. Like, have you ever had too many tests? Were they unit tests? Were they breaking? Were they useful to you? Like, think about what you want to achieve with a test suite, what kind of results you want, stuff like that. But really, what about mocks? Right? You still kind of want to mock something sometimes. You can still use the unit test mock. It works, just works. You have pytest mock that wraps it. It gives you a mocker fixture. And I don't know, I'm still gonna try and guess what, oh shit, this doesn't work without me clicking the thing. So now I spoiled the whole thing. This was supposed to be me trying to guess your reason for mocking, but my guess would be third-party calls. That's the most sensible one. If you're okay with that, after everything I've shown you, if you're okay with writing to your database, then it's the third-party calls that are a problem. So manually mocking third-party calls is kind of a hassle, right? So you would need to probably have some form of a client that you wrap it in so you can override it and then just pass the result in your mock, which is not a bad thing. Like you might want to have a layer for wrapping your outbound requests either way, right? It's not a bad way to go, but you still need to take care of the data and you assume what the third-party API looks like, which is sort of bad. Like you can't really make those assumptions. So what I propose instead is let's automate the mocking of third parties. There's a library called VCR. Ruby did it first. It's freaking brilliant. It effectively records interactions and replays them for you. So instead of having the whole thing from before where you mock patch or whatever, you literally just slap a mark on it and it figures out anytime you do an HTTP request, it says, okay, record this for later. As far as I know, it only works with HTTP. I would love to see this for basically every other protocol. I want a way to just cut off any socket that goes out of my app, record what it does, and replay it. It'd be perfect. If you know anything like that, please let me know. For now, HTTP will have to do. So this thing actually handles that. pytest VCR wraps it. As I said, every library we mentioned will actually have a pytest plugin, and you'll actually want to use the pytest plugin to have the marks for you. So first time you run it, it'll actually reach out to the third party. It will actually reach the bank and it'll record the interaction. So that makes a new cassette because, you know, VCR analogy and everything. And next time you run it, the third party call is actually intercepted and replayed from the cassette, right? So let's take a look at what the cassette is. It's basically a YAML file that records everything about your interaction. I had to cut it down here because it's freaking huge. But basically, it's as if you would right-click copy from Chrome's network tab and paste HTTP archive file thingy or whatever. It's basically the same stuff. So by default, it will record the cassette, and then it will try and match whenever your app does a request. It will try to match by method, scheme, host, port, path, and query, which basically boils down to the thing you call it. So get URL, right? If it recognizes that, it'll be like, okay, what's the first interaction I had with that thing? Play it back. Then second time you call the same URL, what's the second interaction I had? Play it back, and so on. So what that means in effect, it's gonna replace your entire test that was integration test thus far with a unit test, effectively. Like one could argue unit test should be smaller, whatever. Point is, it's not gonna call a third party. You're only gonna have a test that's contained in your own app. Whenever it tries to break out, it just plays back the thing you recorded. Perfect. So VCR supports 4 recording modes. Once, the default one, will only record the first time you run it. And then whenever something changes, a new interaction is detected or whatever, it'll raise. It'll break and it'll expect you to say, okay, I need to record new episodes which is new interactions that it spots along the way. Or alternatively, you have the non-recording mode. None is perfect for CI. It will just flat out raise if any unknown interactions are detected, and it will not record anything. You want that in your CI because you want a human reviewing the cassettes, human recording the cassettes, and then giving it away to the CI and being like, okay, this is what I expect to happen. If it doesn't, let me know. And finally, there's all, which you use for re-recording cassette. Basically, if the third party has changed the API, it's fair that the cassette is not up to date anymore, and you need to replace it. So you delete the current cassette, throw it away, and run the test again in the all mode. You do all of that by setting the double dash VC. So yeah, as I was saying, recordings are actually something you want to keep in your VCS. Okay, so why is this great? I mean, if I haven't sold it to you so far, I just want to drive the point back in. So you don't have to create the mock yourself. What's better than that? Like you skip the whole step in preparation. The data the mock uses is real, and you get two tests in one. You effectively have a unit test, which doesn't go out of your app, or you have an integration test, which actually pings a live environment somewhere or whatever environment. And you have a data recording of your interactions, and you can verify that the third-party API has changed, has had breaking changes. This thing alone has saved me so many times when people are gaslighting me into believing like, no, we had no breaking changes whatsoever. It's something on your end. I'm like, I literally have recordings. Your API literally doesn't work right now. Explain. And then we find the differences. And of course, it's them breaking the API, which happens all the time. But this way, you have proof. Easy. And as I said previously, none mode is super extra for CI, where you can detect when you had new interactions with a third party that you didn't expect. It's perfect for making sure that you don't make more requests that you initially anticipated. And what I suggest is actually scheduling periodic, say weekly, runs with the --disable -VCR to test if the third party still integrates. Because if you're always running against the cassette, you will never know if they broke something until it breaks in production. So I'm saying do a nightly, weekly, whatever run to confirm that it still works with their API. That way you can bug them about it earlier. And finally, or yeah, I believe it's finally, yeah, the probably biggest concern for everybody when they do integration tests is like they're kind of slow, they're not as good as unit tests, you know, it's a hassle to run them. So VCR is gonna make the slowness independent of the third-party API speed. So I'm saying make your app faster. That if nothing, that's a reminder to myself, hey, your app is freaking slow, figure it out. And other than that, you can always just run them in parallel. I was shocked how much faster it is. Like if you thought it's slow as is, like it takes ages, it takes X times faster because we now have X cores per CPU. Like I think this machine I'm on is a 6-core, 12-thread, so I can run 12 workers. Freaking sweet. And pytest-django is a plugin that does it for you. You don't even have to think about it too much. You just say pytest-n auto. It will automatically choose the workers, as many workers as you have cores. That's it, I guess. You can just parallelize all your tests. And to recap, it's okay to write and use smoke tests to drive you through your code base. Try and promote them, those driver tests, into full-blown tests with well-understood cases. And it's okay to delete them if they don't help any, if they don't raise your confidence. Try to focus on what the requirement you're implementing is, not on the details. That's kind of what doing integration tests instead helps. And use the tools at your disposal to reduce friction. Like writing tests shouldn't really be arduous. There's so many good tools. Try and invest something in your testing infrastructure. And bonus thoughts, like don't be tied to a particular metric when writing your test. This is mainly like me looking at coverage. Coverage means nothing, like absolutely nothing. It means you have executed every line of your code. Good for you. Have you executed every functionality, every expected value, every possibility that your customer will do? Absolutely not. You just know that you have run all your code. Useless. It's interesting to look into, but ultimately useless. Always focus on how much confidence the test gives you. If it's too messy to give you any confidence and it's not well documented, if it's not well understood, it's not a useful test. It just isn't, especially if it breaks often. Like, just talk to your colleagues, maybe delete it. If you can't understand, what's the point? Test only helps if you understand it. And as I said, do not settle for workflows that make testing a hassle. Like, if it's a hassle, invest in the test toolchain. And of course, I lied about no friction. Tests will feel something like the GIF underneath. Like, you'll just have a guardrail you have a lot of friction against, but it will help you stay on track, and you'll still go somewhat speedy, at least in Need for Speed. So thanks for listening. Let's switch to Q&A if you have any questions. How many is too many is the question. Okay, so how many tests is too many? If you have an API, there are a ton of possible edge cases of users sending nonsense. How deep down the rabbit hole do you go with those edge cases? Tough one, right? Arguably, low amount of test scenarios, large amount of test cases. What I didn't show here is test parameterization, and I'm kind of hoping that I've spurred your imagination enough that you're going to go and check out PyTest and see what they offer. One of the things is parameterization. So I'm in favor of writing a small number of scenarios that are easily understood, and then smashing them with a bunch of expected effective edge cases values or whatever, right? So you kind of want to go for a small number of test scenarios, large number of test cases. And even better, as far as coming up with those edge cases, I would suggest looking into something like Hypothesis. It's a Python library that's supposed to allow you to do property-based testing, where you describe what the inputs are and let the library figure it out. I haven't used it enough. Like, I tried several times, but I'm hoping next time I'll actually include it. Okay, so how do you test parallel writes to database to confirm two concurrent writes to credit change balance correctly? This is a finicky one. So basically, whenever you have race condition tests, they're not really gonna do anything too useful to tell you if it works or it doesn't. It'll behave the same as it does in your app. Like, race condition might or might not happen. But if you really are hell-bent on testing for race conditions, you could literally just have two writes in your test and see if it breaks. Again, I expect it will flip-flop. Sometimes it will break, sometimes it wouldn't. But it's one way to go about it. You shouldn't feel like it takes you too much time. You shouldn't feel like it's something that's getting in your way, right? I would argue first focus on how do you bring value or how do you get value out of your tests, right? So before you do that, TDD makes no sense. As soon as you do that, you'll understand that TDD actually helps you write your code. Like, I literally can't write without tests anymore, because as I've shown you, I actually run the debugger through the whole thing, especially if I know the spec. What I tend to do is I just copy paste the acceptance criteria in and hammer it down into assertions, and then I start coding. It's actually that simple if you have a good acceptance criteria, that is. In TDD, what are benefits of writing tests first? Is it important to you? Well, I sort of answered it, but basically the benefits are being able to reason about the interface. Like, you imagine what's the thing you want to make, what's it supposed to look like, and you can immediately start from acceptance criteria. Because what I find myself when I do code first is I start thinking about the hardest part of the thing that I'm building, which kind of gets lost in what I'm actually trying to achieve, ultimately what the customer expects, right? I'm too focused on the engineering. But when I do tests first, I have a test case that literally says, hey, until this works, this test is going to keep failing. So writing the test first actually allows me to stay somewhat customer-centric, somewhat acceptance criteria-centric. That doesn't mean you shouldn't be writing unit tests that are actually helpful to you, but it's one of the things to consider. Could you please provide more arguments to test behavior, not functionality? Not coverage, what other QA metrics do you use to provide management with information to make an informed decision about the system under test? Right, so I'm not sure how to best make an argument for testing behavior rather than functionality. In my mind, as a matter of fact, they're kind of the same thing. But if you're specifically talking about the implementation details, it should be obvious the first time you refactor. Because in a refactor, your goal is to maintain the same behavior, but change the implementation. If your tests break because of the implementation, you're already seeing the downside of your test suite. It's not helping you move. It's actually holding you back. If you test behavior, your tests are actually helping you raise confidence that what you refactored is still doing the same thing. So your tests should, even your developer tests should kind of observe the system from the edges. They shouldn't focus on the details. And as far as the metrics, honestly, that's a tough one. I don't have a good metric that shows anything about the system. Like the best I can give you is how many P1 issues have you had? Like how many SLAs, how many actual breakages? Like the product that inspired me to make this talk is actually running hands-free right now, making money without me looking into it for over a year now. Yeah, basically, I think there was no intervention whatsoever for over a year. It just works. We've covered every criteria with tests, and we're fairly sure that whenever we need to change something, which we don't nowadays, it will just keep working. So I would argue that there's no good metric that can give you anything ahead of time. It usually just happens once you observe it live. But coverage is not a good one. It's a good one if you want to focus on it being shit. Like if it's low coverage, you possibly have a problem. Like your confidence shouldn't be high in the test suite, right? If you have 4 tests that are running splendidly, that doesn't mean anything about your system. But if you have 6,000 of them, still doesn't mean anything. So, you have to run it to see if it actually does what you expect.
Thank you, Nikola, for being our guest tonight. And thank you for sharing your knowledge with us.
Thanks for having me.
Thank you all of you for joining us tonight and being here. I posted the link to presentation, and I will post the link to Zoom meeting if you want to join us just right after this webinar. So see you there, I hope. Bye bye. Hvala, vidimo se.